Hi class, hope everyone enjoyed the winter break and the holidays and everyone's ready to get back to learning about object-oriented programming, application development in Java. So in this module 2, you'll be first, reading the Xi books. So you'll be reading chapter 3. It doesn't say to read chapter 4, it's not required, only chapter 3 reading and participation activities required, but I highly recommend that you do read chapter 4 and you complete the challenge activities for both chapter 3 and chapter 4, if there are any, because this is going to give you extra practice. And again, with programming, practice is very important. The more practice, the better. That's just like anything. That's how you can really kind of grasp the core essence of these different concepts. So in this module, you'll be reading about reading chapter 3. You'll be going over various topics on objects and some more fundamentals on Java programming. And you'll be working on your first Stepping Stone Lab 1 project. So this is going to be writing pseudocode for your program. Okay, for the final project, the Collection Manager program. So you'll be writing pseudocode for the primary functionality of this program. Okay, so this will involve reading the final project guidelines and rubric document. You want to make sure you understand the task at hand, right? Understand it thoroughly and understand the logical steps that are needed to execute to solve the problem, solve this task. And for writing the pseudocode, you should refer to this How to Write Pseudocode document, as it gives more detailed information on writing pseudocode. And you want to follow the formality that's explained here. And then you also want to look over the Stepping Stone Lab 1 guidelines and rubric document. So we're actually going to go over this in more detail here in this video. So let's talk about Stepping Stone Lab 1. For this Stepping Stone Lab, you're tasked to write pseudocode for the Collection Manager program. So this Collection Manager program is the ongoing project that will be developed through the various Stepping Stone Labs that will be assigned throughout the class. And eventually, at the end of the class, you'll be submitting the final project. So remember that writing pseudocode is the intermediate step between when you first read the problem or task that needs to be solved and writing the actual code that accomplishes this task. So it's that intermediate step in between these two things. So it requires you to first thoroughly read the task, meaning read through, completely have a good understanding of what the problem is that you need to solve. And then you want to sort of think about the necessary steps that will be needed to be taken in order to accomplish the task and solve the problem. So this is going to involve reading through the final project guidelines and rubric document, read through it thoroughly, and then start really think deeply about what is going to be required, what logical steps will be needed in order to actually accomplish the task that it wants you to solve. So I recommend that as you read through the final project guidelines and rubric document, that you take out pen and paper, take notes, and just make sure you have a good, complete understanding of what it's asking you to do. And if any way you're confused on what's being asked, please post your question in the general questions discussion topic on Brightspace. Okay, so once you understand the task at hand, then it's time to write the pseudocode. So the pseudocode is not actual Java code. Remember, it's instead the logical steps written, formally written in plain English words. So depicting the design of the program or the logical process that will be needed to accomplish the given task. Okay, so I suggest that you read this How to Write Pseudocode document for guidance. Okay, this document will explain what pseudocode is, and how to write pseudocode. Okay, so specifically for this prompt, it's asking you to address the following points in your submission. So you want to first analyze the problem that you want to solve. So we talked about this, right? So you want to determine the necessary logical steps that are needed to solve the problem. And so you should break down this problem into distinct steps of pseudocode, right, that will solve the problem. And then you want to create variables that track the various elements in the pseudocode. and you want to use control structures such as branching or looping. So branching is the use of if statements. So if, for example, if some condition, then do something. So if it's raining, then bring an umbrella. If it's sunny, then wear a t-shirt. Else wear a sweatshirt. So this is the concept of branching. It's the idea of branching in different directions based on some condition. Okay, then looping is the idea of doing things repetitively. So iterative tasks, something you're doing over and over until some condition is met, or something you're doing over and over for a fixed number of times. And that's the difference between a while loop and a for loop, which you'll learn about later in the course. And then again, you want to use natural English language to work through the problems. Okay, so I also suggest that you read through these critical elements down here in the rubric, where it actually explains how the points will be awarded. So this is important because I'm going to be using this for grading your assignment. So it's important that you look through each of these critical elements and specifically look through this proficient column and read what's explained here. Okay, and also you want to make sure that you submit this as a Microsoft Word document with 12-point Times New Roman font and 1-inch margins. So now let's take a look at the final project guidelines and rubric document, which explains the problem that you are to solve. So I'm not going to read through this entire document, but I do expect you to read through it on your own thoroughly, so you make sure you understand what's expected for this final project. And you should have done this already in week 1. So let's specifically look at this scenario section. So you'll be creating a program that will help you manage a collection of recipes. Okay, these are recipes, that you have ingredients and use to cook different meals with. So this is the type of recipes we're talking about. Okay, so you will implement 3 classes, one for the main recipe items, so a recipe class, one for the ingredients that are going to be part of the recipe, so this is going to be the ingredient class, and then one for the entire collection of recipes. So this is the recipe box class. So you'll notice that the recipe box class is a collection of recipes, which means it's going to use the recipe class, and the recipe class is a collection, has a list of ingredients, right? Or each recipe is going to have multiple ingredients, one or more ingredients, and so it's going to use the ingredients class. So this is how they're all connected. Okay, and the collection should use a list data structure to store the individual items. Okay, so items and recipes are used interchangeably. Your collection class should include methods like the add item, print item, and delete item that will allow you to add, print, or delete items from your collection of items, so collection of recipes. Okay, so this just explains what the ingredient class is, what the recipe class is, but let's focus on this diagram here. It's called a UML diagram, otherwise known as a Unified Modeling Language diagram. So this kind of explains each of the different classes and the variables. So you'll notice at the top part of each of these boxes, well, each box is a class, right? Here's the ingredient class, the recipe box class. And at the top, you'll notice that there is the variables, right, and their types, string, float, int, and the name. And then there's methods associated with each of the classes. Okay, you'll see that in each of these different classes. And the recipe box class is going to be otherwise known as the driver class, because this is where the main method that you're going to be running the program from will be located in this recipe box class. Okay, so this is where the driver method, so to speak, will be. Okay, so this says, finally, you will also write an application driver class that will allow the user to create a new recipe and add it to the collection. In addition, it should allow the user to see a list of recipes in the collection, and then give the user an option to either see more information about the particular recipe by retrieving it from the recipe list, the collection, or edit an item that is already in the collection or list of recipes. Finally, your program should allow the user to delete an item from the collection. Okay, so this pretty much explains what is going to be expected for the primary functionality of this program. This program, you should prompt the user to either add a recipe, view a recipe, edit a recipe, or remove a recipe, or exit the program. Okay, that's the core functionality, and you should start there when writing your pseudocode. Okay, and then you'll use these classes and specific methods to help this primary core piece of the program. Okay, so this paragraph here is very important, and I would start here when thinking about the logic of how to write your pseudocode. Okay, so what your program should be doing is first it's going to create a new variable that holds the list of recipes, right? So an empty list of recipes, and then we can call this maybe list of recipes as seen in the recipe box here. So you see this is your array list or list of recipes. And then what you're going to be doing is repetitively within a loop, you're going to prompt the user to select if they would like to add a recipe, view a recipe, more information of a recipe, or edit a recipe, delete a recipe, or exit the program. Okay, so this is the next step is when you should use branching. So you want to determine what's the next step to do. You know, which step should I branch out to in order, depending on what selection that the user makes. Okay, so for example, if this user selects to add a recipe, the program should maybe call this add new recipe method, which might have pseudocode within this method that actually adds that recipe to the list of recipes here, right? It might prompt the user to enter the recipe name, the servings, an array, a list of ingredients, the total recipe calories, and then add this recipe to the list of recipes. Okay, so that's an example of what might happen when the user selects to add a recipe. If the user selected to maybe remove a recipe, then you might just remove that recipe from the list of recipes. Okay, so these are just this is the idea of branching, right? So you want to make the next appropriate step using if statements, right? If this, then this. If the user selects to add a recipe, then call the add new recipe method, or if the user selects to exit, then exit the program. So these are this is sort of the idea of branching, right? You branch to different directions, different steps based on some condition, and this condition is what selection that the user makes. So you don't need to write pseudocode for every single method in every single class, right? That's not the point here. Again, the point is to start with writing pseudocode for this driver method, the driver class, right? The core primary functionality of this program. Okay, so you want to start there, and then you can start branching as you notice you'll need to possibly use methods in other classes. You can then maybe write pseudocode for specific methods, so maybe like print recipe. Again, you don't want to write pseudocode for all these getter and setter methods, these get and set methods. So you'll talk about these, you'll learn about these later in the class. These are called accessor and mutator methods, right? So they're used with the idea of encapsulation, in which you want to sort of keep your class variables protected and private, and be able to access them and edit them only through these methods. Okay, but you don't need to write pseudocode for these methods, as it's very simple. It just retrieves or modifies a variable. Okay, but there are methods such as print recipe, or possibly like over here, print all recipe names, or add new recipe. These methods you might want to consider writing pseudocode for. But again, the main piece that you should be writing pseudocode for is this driver method, the driver class, which continuously within a loop prompts the user to make a selection, and then you have branching, which executes an appropriate next step based on the user selection. Okay, and then as you call different methods in other classes based on the user selection, then you can write pseudocode for those methods. So hopefully this makes sense. Don't worry about being perfect with this assignment. Again, this is your first Stepping Stone Lab assignment, and writing pseudocode can be challenging when with little to no programming experience. It becomes easier after you've gone through the process of actually writing code, just because you kind of have an idea of what type of logic you should be thinking about. But you know, this is the first stepping stone lab, so give it your best attempt. Again, start with the main driver class and write pseudocode for this main driver method and build up from there to the best of your ability. Okay, the goal is to have the primary functionality, branching and looping, and make sure that the pseudocode is clear and organized. So here's a quick example of writing pseudocode. So this asks to write pseudocode for a program that collects multiple meal orders, for example, a combo number and drink from a customer at McDonald's. Okay, so this is just an example. So the first step, we want to create this empty list, right? This variable, which can be an empty list called list of meals, which stores the collection of meals ordered. Okay, then you can have a loop here, a while loop. So while some condition, do something repetitively. So while the user option is not done, right, then we're going to do these steps repetitively. So we're going to first display all the different options to the user and then have branching. So this is where the if statements come in. If the user option is 1, then maybe call this method, add new meal. And then add this new meal to the list of meals list, all right, that we created. So because this is a method, you could create the pseudocode, write the pseudocode for this method independently, separately, here, right, in a separate method section. So this might maybe prompt the user to enter the combo number and the drink, Sprite, Coca-Cola, whatever it may be. And then you want to add that meal to the list. So if the user option is 2, then maybe what you do is have another loop where you loop through each meal that's in the list and display this meal to the screen. Okay, and then also you can have other options. If the user selects done, then you say thank you, bye, you exit the program. And if the user selects something that's not on the options, then you can display invalid option selected. And notice the indentation and the structure, the branching, the loops, and you should follow this as well. So if you have any questions, please reach out, and I'm here to help.